Hey guys, Dr. Brown here with Kubo Math coming to you from Tarlac City, Philippines. And tonight we have integration doing the U sub, but we're going to look at how we can change the limits of integration and not have to change back from the U world back into the X world. So let's get after it. Okay, we have a problem here. The integral and the limits are 0 to 1 of x times x squared plus 1 in that parentheses cubed. So, wow, what to do there? Alright, let's let, now you'll notice if you just look inside the parentheses here, you can see if you take the derivative of that, that's 2x. So that would give me an x term to get rid of this one. So let's do that. So u equals x squared plus 1, du equals 2x dx. So if I divide by 2x, both sides by 2x, du over 2x equals dx. Alright, let's see what we have here. I'm going to leave the limits off for just a moment. Okay, let's just write down x, and then we have everything in the parentheses was u cubed. Now dx, we have to replace it with du over 2x. These x's cancel. And let me just go ahead. I'll leave the limits offered one more time. I'll put this 1/2 to the outside. So now I have 1/2 the integral of u cubed du. Now what would our limits be? Well, if we go back up here, let's let x equal 0. So 0 squared is 0 plus 1 is 1. So if x equals 0, u equals 1. What about when x is 1? 1 squared, I better write that down. When x is 1, 1 squared is 1, 1 plus 1 is 2. So u equals 2. So my new limits would be 1 to 2 of u cubed du. Now the value to this is, once I go through the integration, I don't have to change back to the x world. I can leave it in the u world. This is cool. Alright, so I'm going to add 1, divide by that, so that equals 4, and divided by 4. So I have 1/2 times this 1/4 gives me 1/8 u to the 4th from 1 to 2. Okay, so that equals 1/8. Let's do this. And that 1/8 is times all of that. Now then, 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So I have 16 in this one. And then 1 to the 4th, which is just 1. So I end up with 15 over 8. Now you may be thinking, well, why don't we just challenge ourselves and go back to the x world and see what happens? We can do that. We would still have u to the 4th over, let's see, we would still have this situation, 1 times 8, or 1 over 8, u to the 4th. But let's change that back to the x world, 1 over 8, u, which was x squared plus 1 to the 4th from 0 to 1. Okay, let's see here. All right, we've got 1/8 times everything that's in there. All right, so we've got, I probably didn't have to do all that with these simple numbers. 1 squared is 1, okay? 1 plus 1 is 2. 2 to the 4th is what we would have here, minus 0 squared is 0, plus 1 is 1, 1 to the 4th is 1. Let's see, 2 to the 4th, 2 times 2, times 2 times 2 is 16, so I have 1 over 8 times 16 minus 1, which is 15 over 8. So you can see you get the same results. It's just a matter of if this is some complicated function and you've simplified that by changing it to u, if you can get your limits to be something associated with u, you just don't have to change it back. That's the beauty of this situation. Okay. 15 over 8, 1 down. Pick a different eraser here. Hopefully everyone's been studying. Best way to get better is work problems. I met today with a principal here locally, and she was talking about the challenges they have in their schools. So let's support our kids. I say this with every video. Support the kids in your local area, whatever country you're in, whatever town. Support the kids. Workbooks, notebooks, pencils, paper, dry erase markers, whatever it happens to be. Just what are the needs of that school? Get linked up with them. Let's help these kids. This is one of the reasons I make videos. I don't make any money on any video at all, and probably never will. But I try to pick subjects that the kids are communicating with me that, hey, I need this, I need that, how do I do these things? And we try to make the videos associated with that. So sometimes they may not follow a good sequence. It's just because there's different children around saying, hey, how do you do this? So we try to make a video for that. All right, we got the integral from 1 to 5 of x over the square root of 2x, I think that's minus 1, dx. Well, all right, let's just let u equal square root of 2x minus 1. Okay, if I do that, u squared equals 2x minus 1. If I square both sides, that radical drops away. All right, now then, let me take the derivative of this. So if I take the derivative of both sides, I get 2u du equals 2 dx. Okay, now to divide both sides by 2, I have u du equals dx. Now I still have, you'll notice I don't have anything to get rid of that x right there. So let me take this situation here and solve it for x. So I'm going to add 1 to both sides. So I have u squared plus 1 equals 2x. Now divide both sides by 2, so I'd have u squared plus 1 over 2 equals x. Now then, I think I have everything I need. I'm going to leave the limits off for the moment. X is this term, u squared plus 1 over 2, divided by, that's x, divided by u. Now dx was u du. Oh, the u's cancel. So I end up with the integral, and I'm going to take this 1/2 to the outside, u squared plus 1 du. Now then, let's figure out what our limits are. Okay, they go 1 to 5. So if, let's just work with it here. If x equals 1, I really should do those in the order that I'm going to write them down. If I take, if the limit looks like that, I would do the upper and lower, just to make more logical sense. All right, so let x equal 5. 2 times 5 is 10. 10 minus 1 is 9. Square root of 9 is 3. So u equals 3. If x equals 1, 2 times 1 is 2. 2 minus 1 is 1. Square root of 1 is 1. So u equals 1. All right. I'm going to break this into two integrals. So I have 1/2 the integral of u squared du plus 1/2 the integral of du. So it's 1 du. And that would be from 1 to 3. 1 to 3. Okay. Now then, so I have 1/2, well, 2 plus 1 is 3, divided by the 3. So I have 1/2 times u cubed over 3 plus, and that's from 1 to 3, plus 1/2, the integral of du is u, 1/2 u from 1 to 3. All right, let's go up here. We have 1/2. I'm going to do this, a little extra work here. That was one of those. That's from 1 to 3. So I've got u cubed. So I've got 3 cubed over 3 minus 1 cubed over 3, which 1 cubed over 3 is just 1/3, plus this integral of 1/2. Got a similar situation here. I do the boxes just to show people, I mean, obviously these are simple functions, but it just helps you keep up where the numbers come from. Now eventually, obviously you won't do this, but it just helps some people break it out and stay consistent. So now we're working with this integral. We have 1/2 times 3, u is 3, 3 minus 1. So I just have that situation here. But it's 1/2 times all of that. Okay, now 1/2 times 3 cubed, 27. 27 divided by 3 is 9. So 9, well, let's just keep the third in there since we have a third here. So we have 27 over 3 minus 1 over 3 plus 1/2 times 3 minus 1, which is 2. So that's times 2, which obviously is 1. 1/2 times 2 gives me 1. So what we got? 26 over 3, 1/2 times 26 over 3 plus 1. Well, that's 26 over 6 if I multiply that in there. And 1 is 6 over 6 to get a common denominator. So 26 over 6 plus 6 over 6 gives me 32 over 6, which is 16 over 3. There again, that would be a way to not have to put this function back in there. Now I have a radical. It just makes it a little bit easier. We'll take the next one and convert it back to the x world. Let me pause the video and I'll clean up the board and get the next problem up there. Okay, we're back. All right, now we have the integral from 1 to 2 of 2x squared times the square root of x cubed plus 1 dx. Well, if you look at x cubed, the derivative of that would be 3x squared. So that would help me get rid of the x squared term. So let's try that. So let's say u equals x cubed plus 1. du equals 3x squared dx. So du over 3x squared equals dx. Okay. Do I need to do anything else? I'm going to leave the limits off for just a moment. 2x squared times u to the 1/2. So that was u, everything that's inside or under the radical, so u to the 1/2. Dx is du over 3x squared. So the x squared terms cancel, but I'm going to take this 2 over 3 to the outside times the integral of u to the 1/2 du. It's amazing how this starts simplifying so much. U sub is awesome. It might take something that you think, oh, what do I do with that? Down to, oh, okay, no problem. Now then, let's work on our limits here though. When x equals 2, u equals, so 2 cubed, 2 times 2 is 4, times 2 is 8, 8 plus 1 is 9. Oh, that's kind of getting big, isn't it? So when x equals 1, 1 cubed is 1, 1 plus 1 is 2, so u equals 2. Well, that's what we have. Let's see what that looks like. 2 to 9 versus 1 to 2. Although, this looks simpler than getting back into that. So, alright, let's keep rolling here. Alright, so if we increase this by 1, that's 1/2 plus 2 over 2 is 3 halves. So I've got to divide that by 3/2, which is the same as multiplying by 2/3. So now I have 2/3 times 2/3, which is 4 over 9, u to the 3/2 from 2 to 9. Make certain 2 has 3, yep, so we're good there. Alright, let's see what that does for us. 4 over 9, and now I have this situation. Of course, 4 over 9 is multiplied to all of that. So I have 9 to the 3/2 minus 2 to the 3/2. Well, if you know that you remember the rule. If I have a to the m raised to the n, that's a to the m times n. Well, I have that situation here. I have 9 to the 1/2 raised cubed. That's what to the 3/2 is. So the square root of 9 is 3. 3 cubed is 27. So I have 4 over 9 times 27 minus 2. Wow, this is a little different here. Okay, I've got 2 to the 1/2 cubed. I mean, it's same in that respect. So what is the square root of 2? Okay, if I say, well, I've got the square root of 2 cubed, I have that situation here. Square root of 2 times square root of 2 is 2. So now 2 times the square root of 2 is what? It's 2 square root 2. Okay, I'll leave it in that form. 27 minus 2 square root 2. Okay, times 4 over 9. So 27 divided by 9 is 3. 3 times 4 is 12. Now 4 over 9 times this, 2 times 4 is 8. So I have 8 over 9 square root 2. And that would be the answer. I wonder if we could take and go back to here. We had 4 over 9 u to the 3/2, but if we substituted for u, could we get the same answer? Oh, let's try that. All right, let's see if we can do that. All right, so we had 4 over 9 u to the 3/2. Okay, and that's same as 4 over 9 u, which is x cubed plus 1 to the 3/2. But that limit is 1 to 2. This is what we've been doing all along, was going from x world into u world and then subbing back in, going back to the x world. This, by changing the limits to u limits, we didn't have to go back. But let's just see here, see if we can come up with that same answer. Okay, so I have 4 over 9 times 2 cubed. 2 times 2 is 4, times 2 is 8. 8 plus 1 is 9. Should do this. And 4 over 9 times all of that. So I have 9 to the 3/2 minus 1 cubed, which is 1, plus 1 is 2. So now I have 2 to the 3/2. Oh, this is looking very familiar, isn't it? Okay, 4 over 9 times square root of 9 is 3. 3 cubed is 27 minus 2 square root of 2 cubed is 2 square root 2. So that looks very familiar, doesn't it? Okay, so all of that equals 12 minus 8 over 9 square root 2. But since this function is a little bit more complicated than just this, you know, we had that extra step of taking it back. Every step you have, it's the increased chance of making a mistake. But I guess your debate could be, well, you had to add these steps in to change the limits, and that's true. But this was pretty simple. So, okay. That is how you change the limits from going from X world into the U world, and then changing your limits to make them U limits, if that's the correct term to view that. Okay, why are we doing this? Hey, together we're trying to build a better tomorrow and do that through math. This is all for tonight. Keep studying, and we'll talk to you next time. Thanks.